Welcome! Today we'll learn how to find the derivative dy/dx using implicit differentiation. Let's start with the equation we're given. To find dy/dx, we need to differentiate both sides of the equation with respect to x. Remember, when we differentiate terms containing y, we need to use the chain rule and multiply by dy/dx. Let's differentiate each term one by one. First, the derivative of x to the fourth is 4x cubed. For the middle term x squared, y squared, we need to use both the product rule and the chain rule. And finally, for y to the fourth, we get 4y cubed times dy/dx. Putting all these terms together, we get 4x cubed plus 2x, y squared plus 2x squared, y times dy/dx plus 4, y cubed times dy/dx equals 0. Now, let's group the terms with dy/dx on one side and the other terms on the other side. We get 2y times x squared plus 2y times 2y squared, all times dy/dx equals negative 4x cubed minus 2x y squared. We can factor out a negative 2x from the right side. This gives us 2y times x squared plus 2y squared times dy/dx equals negative 2x times 2x squared plus y squared. Finally, we can solve for dy/dx by dividing both sides by 2y times x squared plus 2y squared. This gives us our final answer. dy/dx equals negative x times 2x squared plus y squared all over y times x squared plus 2y squared. Let's review what we did. First, we used implicit differentiation to differentiate both sides of the equation. Then we used the product rule and chain rule where necessary. Finally, we grouped terms and solved for dy/dx. And that's how we find dy/dx using implicit differentiation. Remember to always use the chain rule when differentiating terms containing y with respect to x.